Has this ever happened to you?
Have you been running with your fitness watch and it ran out of battery? Ever lost track of the mileage on your shoes, causing you to damage your knees and shins with worn out shoe soles? Well, that's where Better Step comes in. Better Step is an all in one solution to step counting and charging.
BetterStep's built-in power generation harnesses the user's natural movement similar to how a watch movement winds an automatic watch. It does this through a magnet that's supported by springs that floats in a copper coil, and as the runner runs, it resonates with the natural running frequency.
As you can see, my steps taken are shown on the serial monitor, as well as the distance I've traveled and the voltage of the battery. This shows the battery level, and it'll raise as you run. This also works at varying different running and walking speeds, so it'll work if you're out for a morning walk or a heavy run.
For initial testing, we originally had just the logic board on its own attached to the computer with a manual corded readout to see if we could get sensor and step data reliably. To validate that the power generation would work before integrating the battery system, we wanted to make sure that the coils were capable of producing a high enough voltage for the buck converter so that it would be able to power the charging circuit for the LiPo. So we attached it to a shoe and ran around with it to see if it was able to generate enough voltage, and it was able to get up to 2.6 volts at least. The next thing to test was the LiPo charging functionality. So starting out with 3.9 volts on the LiPo, we have the rest of the circuit here with the charging and buck converters. From this, it was able to generate enough power to boost the LiPo up to 3.97 volts. As you can see in this diagram, LiPo charging is non-linear, and so the 0.07 voltage increase was able to charge about 2% in that part of the charging graph. So from that 2 minutes of use, we were able to gain 2%, which will be able to keep up with the demands of the ESP32.
So the first thing that happens is that the Arduino will update the current acceleration of your foot when you start to take a step. Next, the Arduino will check if the acceleration that it just measured is greater than 575. A value found was very accurate in checking if you're actually taking a step or not. Next, it'll check if the previous acceleration that was measured is less than 575, so double steps don't get counted, and it'll only record one step every time. If both of these conditions are true, it'll increase the step counter by 1. Otherwise, it will only update the previous acceleration. After that, the Arduino calculates the distance that you moved based on your stride length, and also calculates the voltage of the battery using a voltage divider. Next, the Arduino checks if the distance you've traveled is greater than the predetermined distance threshold, which will let you know if you need new shoes or not. If this is the case, the Arduino will trigger a warning to let you know to get new shoes. At the end of every cycle, the ESP32 will send a packet of data to the Arduino R4, which is what will actually show you all the data and your step count. This first piece of code is what first gets your acceleration from the accelerometer, and then it'll check if the conditions are met so that the step counter increases by 1. The delay is there to not get duplicate steps. This piece of code turns all the data that the Arduino has gathered and turns it into a packet that it can then send to the R4. Finally, this code is on the Arduino R4 side, which will read the packet sent to it by the ESP32, decipher it, and then print out the info in an easy to read manner for the user, which will tell you the distance you've traveled, the voltage of the battery, and if you need new shoes, it'll let you know that as well.
As for the wiring of the system, the schematic on screen demonstrates both the charging and the logic parts of the circuit. On the right, you can see that there is the AC power source into the diode rectifier and the capacitors that are used for smoothing. In parallel with those is also a Zener diode, which prevents the voltage in the capacitors from exceeding 5 volts, which goes into a buck converter that steps up the voltage from the roughly 2 volts to 3 volts to a consistent 5 volts that then goes into the LiPo charger. The LiPo charger ensures that the battery is not overcharged and also not over discharged. From the LiPo, there is a voltage step up, which steps up the 3.7 volts roughly of the LiPo to 6 volts that is then fed into the ESP32 and allows it to have a consistent source of energy. There's also a siphon off of the LiPo into the analog port of the ESP32. This is in order to read the voltage off of the LiPo through a voltage divider. Finally, the accelerometer and the ESP32 are connected through an I2C bus, allowing for serial communication between the two of them.